Find the surface area generated when the graph of the function y equals x cubed over 3 for x is between 0 and 1 is rotated about the x-axis. The first step in the process is to choose a setup of the integral that's going to get you to calculate surface area. Since it says rotated about the x-axis, then the formula in general for surface area will be 2 pi times the integral of y ds. It's because y is the radius. Now, we have a choice. We could do this integral in x, or we could do it in y. If we do it in x, then the following has to happen. The y can't stay as a y. It needs to be changed. So you replace the y by f of x, and then the ds is a part of the arc length, and so it's from the arc length formula, and that's also going to be in x. Now, if we decide for some reason that we would like to keep it to do it in y, then the y can be kept as a y, and then when it comes time to do the ds, it'll be 1 plus the y version of the arc length formula. So it depends. You should go off of what they give you and try to reason from that. We are given y is a function of x, and we're given an x range. So that's a hint that maybe we should try to do it in x. And if that's the case, then we'll replace y by f of x, and we have the arc length formula in x. And we're going from x equals 0 to x equals 1. Now on to step 2. Step 2 is for us to simplify this ds, this derivative squared add 1 square root. So let's simplify that. If y is x cubed over 3, if f of x is that, the derivative is x squared. The derivative squared is going to be x to the 4th. 1 plus the derivative squared will be 1 plus x to the 4th. The square root of that is just going to be the square root of 1 plus x to the 4th. Okay, great. We've simplified the ds part. Let's move on to step 3. We're going to plug in and we're going to integrate. We had this formula from the first slide. Replace f of x by your function and replace the root by your simplified version. So f of x is replaced by x cubed over 3, and the root is replaced by 1 plus x to the 4th. Let's pull the 3 out, and we're looking at x cubed times the square root of 1 plus x to the 4th. Because x to the 4th is 1 degree higher than x cubed, that's a hint that you should try to go for u substitution. Let u be 1 plus x to the 4th. Its derivative is 4x cubed dx. And so we take 1/4 of du, that's going to take the place of this x cubed dx. Don't forget we have a 2 pi over 3 also out there. And we take the 1/4 out, and then the root will be replaced by u to the half. Okay, the 4 can be turned into a 2 by the 2. So we're talking about pi over 6. And then when we integrate u to the half, we get 2/3 u to the 3/2. So then this 2 can turn this 6 into a 3. And ultimately we're talking about pi over 9 u to the 3/2. U substitution is just sort of side work to help us figure out what this antiderivative in our current problem is. Replacing u by x, we'd have pi over 9, 1 plus x to the 4th to the 3/2. Not replacing u by x, but replacing by u by what we set up for our substitution. That's to the 3/2, and we have to evaluate from 0 to 1. We plug a 1 in, we get 2 to the 3/2. Plug a 0 in, and we get 1. And you can just leave it like that. There's no simplifying that. So the final answer to the arc length between 0 and 1 of this function is pi over 9 times the quantity of 2 to the 3/2 minus 1. You might see this 2 to the 3/2 written as 2 root 2. But that's the answer. Okay.